about linear transformations of predictors in the linear model. The main message is that linear transformations to x or also to y, but we concentrate here on the linear transformations to x, they do not change the model. So it means that mathematically and statistically the model where a linear transformation has been made to x is equivalent to the original model. Let us see what does it mean formally. So assume that we originally have a predictor x1 and then we make a linear transformation to this and save this transformation to variable x2. And here a and b are fixed constants in this formula. And then let us write a linear model where this x2 is a predictor in the model, the only predictor. Let us then write this transformation in the place of x2. So we get this kind of formula first, and then when we simplify it, we get this on the bottom row, and now you can see that we can denote this by beta 1 star and this by beta 2 star. So the new model is still linear model of xi, but now the beta 1 and beta 2 parameters are functions of the parameters of the model that included x2 as a predictor and our parameters a and b of the transformations. This model is equivalent to the model we had originally, but the parameters have different interpretations. And therefore, because the models are equivalent, then the user can select either the original model that includes x2 as a predictor or the new model that includes x1 as a predictor, and therefore the person that is doing the application, the researcher, is free to choose the values a and b in such a way that the parameters beta 1 and beta 2 have nice interpretations. One good choice is to select the following. We select a case transformation where we subtract the mean of x1 from the original values of x1. So this is a. It means that in the transformation, linear transformation, here a is selected to be minus x1 bar and b is 1. So now in this case the original model that includes x1 as a predictor is shown here, and especially the intercept here is the value of expected value of yi when xi1 is 0. But now if xi1 ranges, for example, on the positive side, that it ranges within this range and the mean is here, the new transformation moves the coordinates in this way. So this red line now shows the moved coordinate system. And now the line, we have the same line as before, so the model is the same, but now it is defined in the new coordinate system, and therefore the value for this beta coefficient in the new model that is shown here using the red color. So the intercept of that model shows the value of the fitted value for the x value that is the mean of the x1 in the original data. So now in this case we can change the interpretation of the intercept term, and sometimes the red option is better than the one shown in the black, but not necessarily always. So the researcher needs to select what he or she wants to use. So the message of this video is that a wise modeler selects the transformations that best serve the purpose of the model, and hopefully you will be the wise modeler.